Welcome everyone to September 24th SIG Node meeting. We have a packed agenda, so let's get started. Just as a note, we should do a little bit of kept planning right at the end, so we may want to hop to that if we're taking a while in the existing issues, but we also want to try to get through some of the agenda because we haven't been able to do that because of kept planning. So first up, we have James with Windows kept updates for CPU memory manager.
Yeah, so we've kind of finished from the SIG Windows side and have a prototype working. So I just wanted to get some folks to take a look here. Sergey, you had mentioned we maybe need a different kept for this with some feature gates. In a previous conversation, I think a couple months ago, it was kind of thought because the feature is GA, there's no major changes to the feature, and it can be disabled with CPU manager none or memory manager none, that a whole new kept wasn't required. So I'd just like to flush that out so we can get that moving forward if we need to.
Yeah, I vaguely remember this conversation. I didn't rewatch recording, and I think you pointed a comment that Peter summarized what we discussed. I have some mixed feelings about updating GA feature, and for memory manager, same feeling, like we will GA feature, but also we're working on something that is not GA specific for Windows. I feel that that's strange a little bit, but your point that it can be disabled if needed. I mean, yeah, I guess it qualify. So, yeah, as long as this PR will be merged into those caps, and some nodes will be. How do we plan to track documentation, for instance? Do we plan to track documentation also outside of any cap planning? Like,
I guess typically, well, I thought like once the feature kind of merges, we can add documentation as part of the release cycle. So I guess that was my plan.
okay.
Yeah, so far from what we have, like the features that memory manager and the CPU manager provide haven't changed. Like there's nothing specific from the Windows side, since we're essentially just kind of plugging into the C advisor API that's exposed and just providing the information there, and then the rest of it works. So I guess from a documentation standpoint, it's just going to be, hey, Windows now has support for this if you want to try it out.
And you don't plan to tell Windows users that something that is in beta support and try it carefully, and then you want to progress to like full support, GA support, and you're saying basically you are GA-ing from get-go, right? So it's go straight into GA, but you can still disable it. I mean, KEP provides all these like nice properties, right? One property is you can tell customers about readiness status, and documentation team will track it for you. All those nice properties that we're losing with this KEP, and like I was a little bit confused.
Yeah, I don't. I guess I can see pros and cons both ways. So I would look for guidance from the group here to move forward on it.
Another option that we have is the CPU manager at least has a feature gate, which just is a bucket for all of the alpha features that go into CPU manager. I don't know if memory manager also has that, but like for all the different policy options, but theoretically we could also put Windows support into that bucket, saying like, this is, a newer feature, even though it's part of overarching CPU and memory manager. So to associate it as like, a less developed feature, but also not have to introduce a new feature gate. That's another option. I still, I mean, I guess it depends on, how the SIG Windows feels about the maturity of this feature. Like if this is something you're willing to just, say like, we're giving it the check, this is GA, like we don't expect the behavior to change very much. We don't, obviously the APIs aren't changing from the perspective of, so that helps. those are stable APIs. But if the behavior you think is going to be pretty consistent, then I would say that's up to you all to decide.
Yeah.
May I suggest something?
Mhm.
My principle normally for this kind of things, it is we need to empower Windows support, Windows Node support, but to carefully signal, to carefully make sure those change not add maintenance overhead to Linux node. But SIG Windows actually it is the expert compared to us, and container technology anyways new to Windows. So everyone's doing experimental. So this is why in the past I basically just trust them, but always only focus on is this one add more overhead to Linux nodes, all those kind of things, but empower them, make sure their velocity so they can iterate faster. And we also can maintain in the long run because definitely it's the same. There's some of the code paths. So that's kind of I hope we still keep some principle here. So we can enable certain things because this is kind of still people try, right? So we should allow some inconsistency to some degree, but not add too much of the overhead. If we can maintain not too much overhead for our team, I basically trust the SIG Windows more.
Yeah, I think like by skipping the KEP process, we are kind of like jumping alpha, beta, GA directly, right? So I feel that we owe the users at least saying that this is entirely new code. And at minimum, I think there should be a beta stage, right? Or they'll be under the false impression that this is GA. And I think it may work out better for you too, because you can set the right expectation that, okay, this is new in Windows, it just landed, it's beta, give us some feedback, and we can take one more release to call it GA. Since we're not touching the Linux API, maybe we can skip the alpha phase, but I'm thinking that that could be a compromise here.
Can I say that I even don't know they skipped beta? My comment is based on they were GA'd. I don't know they skipped beta, that's for sure.
Yeah, I don't know that we have a mechanism to be able to communicate that effectively without going through the KEP process. So,
so I think like Derek is also agreeing in the chat, and I think maybe we just add a flag at beta and not enabled or something, and then we take it to GA. We don't want to like rush things directly to GA. Even for small features, we've asked people to write KEPs.
Yeah.
So yeah.
Okay. I'll take that back to SIG Windows and we'll go from there.
To my question, one of the reasons I was agreeing with Renal is this code has been really difficult to test in practice, and I was just kind of curious, like if I could see the KEP, like what is the Windows unique test plan, right? Because I know we have had regressions in this code area over the years, or we thought things worked the way it didn't actually work when put into practice. So like the part that gives me hesitation is like if it's a real mission critical workload where the CPU assignment is needed, it tends to have like a low fault tolerance, and just understanding holistically how well it's been tested around the edge cases is really helpful. For the users I tend to support that are working with us, they're in telco environments, and so where we've had bugs, it's been really bad. And so I don't know in the environments where you're looking to use this feature, but I would just try to keep that in mind, like depending on the industry that's looking to exploit it.
Okay. Yeah, that was one of the comments Sergey had mentioned was around the test plan. I think one of the challenges we have is the EDE node doesn't work on Windows, but I did a little prototype a couple weeks ago to see if I could get some of that running. I was able to, which would potentially open up the door to be able to run some of the types of the test cases that are being run against the CPU manager today. So I think I don't want to take much more time here. So it sounds like there's a big agenda. So I think I've got what I need, and I'll go back and try to summarize that on the issue.
Cool. Thank you, James. Next up, we have Tim.
Hello. Can you give me screen sharing abilities?
Yes. There you go. Co-host.
All right. So yeah, this is just continuing the presentation on in-place pod update that I started. I think it was 2 weeks ago. We only got through part of it. I'm going to try and go really fast here because I don't want to. This could probably easily eat up the entire rest of our time here. So we'll just try and kind of skip through some things. I wanted to pick up where we left off on the QoS class changes because there was a bunch of questions that folks raised about that, and I have a bit more detail here now. So just to recap what I'm proposing, the simplest way of saying it is no matter what you resize the pod to or the container to, the QoS class does not change. So the original QoS class, when the pod is created, is fixed. And so given that, you are allowed to resize the pod such that it's the shape of a higher QoS class than the original. You're not allowed to resize it so that it's the shape of a lower QoS class. So in other words, if you start with a guaranteed pod, you are kind of locked into being guaranteed. So you must maintain that you have CPU and memory requests equal to limits. If you've got to start with a burstable pod, you are allowed to resize it such that the CPU and memory requests are equal to the limits. But you're not allowed to remove all of those requests and limits. And then best effort kind of can freely resize. And so in practice, this is where some of the questions came up. Like, what does this mean in practice, that things are going to be looking at the QoS class explicitly instead of kind of computing it on the fly from the shape of the resources? So the implications are the pod C group doesn't change. It's, no matter how it's resized, it stays in its original QoS class C group hierarchy. Non-guaranteed pods are ineligible for guaranteed CPUs or NUMA pinning. Actually, this is sort of obsolete because I think we're going to say that CPU policies and topology is out of scope for beta. So I still need to write an update for that. But basically, we'll say if you're trying to use static CPU policy with a guaranteed pod, we will forbid resizing the pod. Preemption uses the original QoS class. There were some questions around this because preemption uses priority, but actually once the candidate pods for preemption are picked up based on priority, they're ordered based on QoS class. So this will use the original QoS class. Score adjustment is also calculated with the original QoS class. And memory pressure eviction is unaffected. This is just based on how close usage is to, I can't remember, requests or limits, but it doesn't use QoS class in the calculation, so that's unchanged. Any questions on this?
I had one. What exactly is the motivation for changing the QoS class?
Well,
just reacting to, like, if you change the request limits, and that it should be changed.
So again, the proposal here is to not change the QoS class.
Okay.
Are you asking what is the use case for changing the shape of the requests and limits so that it looks like a different QoS class, or are you asking, like, should we be considering a use case for changing the QoS class?
I guess, sorry, I was distracted. Maybe I missed the implications of this. I was just seeing the QoS class, so I was curious if it really is like a lot of use case for changing them.
Yeah,
or not.
got it. No worries. But yeah, just to reiterate, the proposal is that the QoS class is fixed at creation time. Sergey?
Yeah, I have a couple questions. First is a little less related to the change you're proposing, but what you're saying is we will disallow topology manager and resize of a pod, but topology manager configuration is only on a node. So we wouldn't be able to do this validation on the API server. And then it will result in like more changes being rejected on the kubelet side. And I made the same comment about C group v2 support and C group v1 support in pod level resources with Dixie. If we add more and more checks like that, like with admission being only checked on kubelet, we're getting into a lot of situations when pods being rejected when API server seems that they're perfectly fine.
Mm-hmm.
See any problems here?
Yeah, it's a good question. So the API of that would look like the pod, the resize being marked as infeasible. I think the other option is I'm suggesting that we need a node runtime feature for this anyway, to say, like, is resize supported at all? That's currently all or nothing. So we could say that if you've configured static CPU policy, like all resizes are unsupported on that node. We could also potentially break it out to some sort of subset of that. But I'm worried that if we kind of try and be really granular about, like, okay, if you're resizing this specific shape of a pod, then we're going to forbid it. That is getting a little too complicated. This is also the motivation here is basically just to lower the scope for beta. I think long term, we need a more sustainable solution here.
Hey, Tim, I think what you're proposing here is reasonable. I think some of the areas where these kind of more advanced scheduling features intersect with resource resizing, in some cases, like a lot of the users, it's at odds with what they want. Like, so I guess I would bias the same way you are here, which is try to get something functional for like the non-specialized scenario, and then move forward after that. So I like the ideas you're presenting.
Yeah, thanks.
And second question I had is, do you have like list of why we even want to allow change of QoS cloud based on resource calculation? Is there like strong need for that? I see a lot of problems from people getting like you get basically in a situation when some pods can be changed the QoS status based on resource calculations because they were in previous QoS class before. Like if you going from burstable to guaranteed, for instance, I'm not sure, like in latest proposal, will you allow to go in a guaranteed, or you wouldn't allow to go into guaranteed? But like, if you disallow some of the transitions, then we were in situation when if pod used to be in guarantee and then went to burstable and then it goes to guaranteed again, then there is like we allow to do that. And if it started with burstable, we wouldn't allow to go into guaranteed.
Yeah, so the KEP goes into more detail on this. I think the case that you're talking about is, let's say you've got like a bunch of replicas that you're resizing, and you start out burstable, you resize them to guaranteed, then you horizontally scale. And so now some of your new replicas are starting out in that new state of guaranteed. So now you've got a mix of pods that are all the same size. Some are burstable, some are guaranteed. Then you try and scale back down, or kind of revert to the original of burstable. The ones that started in burstable can do an in-place update, and the ones that are now guaranteed can't. The way that I proposed handling this in the KEP is a kind of a new feature where we make QoS class an explicit thing in the spec. But again, that's kind of a new feature, kind of a sort of something that I want to say, let's worry about that in the future.
I guess my question is, should we even allow to change QoS class today, or we can worry about this in future?
Mm-hmm.
Yeah, Sergey, when I reviewed this with Vinay back when it was in the alpha discussions, like it's a huge simplifying factor if we don't switch QoS classes. And so and since that was the original design goal, like I kind of view the current feature progression as resize within a quality of service class, and then it'd be a separate feature if we ever wanted to do resize into a new QoS class, because the implications are really big and tricky. So I feel like if we change it now, we're kind of taking on more scope than probably needed, and
Yeah,
it was intentionally excluded.
Should just don't allow to change QoS class based on calculations. So if you user trying to get request to limit when they are burstable, we will just disallow it on API server.
Yeah, my brain's a little foggy on if that was in the original implementation that Vinay had put forward, but it was
that's how it works
reasonable
today.
and in the spirit of it.
So that says you can't set requests equal to limits on a burstable pod. It also means that you can't do any resizes on a best effort pod. You can't add limits to a best effort pod.
So I just want to say that I think the surrogate, even internal discussing, I repeatedly say it's impossible. We change of the cognitive health service giving, because that means that while you create of this C group, right? So based on the layout of the C group, there's no way for us to move cleanly those running process and make sure all those charge, right? So because during the runtime and make those, especially like for memory charge, is accurate. So let's not go over, because implication is way more harder, and also it's not worth our engineering time to do that. Let's just say, okay, you start with this QoS. And also, I think I repeatedly give all the cases, like how we do the score and calculation, and also preemption, eviction policy. All it is actually, it is still give the file treatment for those. So that's why I feel like that it's not over engineer this one, because really cannot work. We have the experience before.
I don't think anyone's advocating for changing the QoS class. I think the question here is, do we allow you to do a resize that takes the shape of a different QoS class while keeping your QoS class fixed? So can you set while staying burstable, can you set requests equal to limits in a resize?
Yeah, I'm with you on that. Like I want to stop as early as possible in over engineering, and I feel that we entering, like, first we need to introduce checkpoint for Kubernetes, that is extra step, and then we also get into this inconsistent state with what calculation of QoS class and what is actual QoS class. Instead, let's just disallow this change. Let's just disallow to change the shape of code, and I mean, guaranteed can change request and limit together, and everything else can like be resized as much as you want, unless you're doing request equal limit.
Yeah, and I thought that was the original KEP and spirit of the design. So I guess I would be +1 on restricting that invalidation.
Yeah, that's the current implementation and the current design. So this was proposing kind of relaxing those constraints for the beta. Yeah, I mean, I'm fine narrowing the scope for beta. I do feel like this feels a little like an kind of an artificial restriction that I think users are going to bump into and be a little confused about. But I'm fine with saying like, well, we'll address it in some sort of future update.
Tim, I'm sorry. Are you proposing to not do the validation or to relax the validation?
To relax the validation.
Oh yeah, I would argue we need to do the validation and not relax it.
I also agree, especially that simplicity, what Sergey and Derek present here.
Yeah.
I really think we should do the validation and enforce validation. I even don't think about we should revisit that in the long run.
I also think, Tim, it could be an attack vector if we don't do it with memory backed volumes. So I think we need the validation.
Yes.
Okay.
No matter what, you are going to do the validation. Trust me. Because you have to check off your request. It is at least less and equal to limit. Right? So whatever you still doing that kind of thing. So that's why make that less than limit. Make that stay as burstable. A lot of things can change. I finally get what Sergey is saying. Thanks.
Okay. So just for me to understand, so the comment is to make the API validation to be a must for the beta, correct?
Right. I would argue that it's a must that you can't change QoS class, and that's enforced in validation for beta.
Okay.
Yeah. So we're going to maintain the current behavior. Yeah, I'm fine with scoping down for beta. Okay, let's move on then. So limits, semantics, and resource quota. Limits is sort of the last remaining kind of unresolved piece that has the potential to block beta in 132. So the current behavior is that there's kind of just reminder for folks. Did I put that slide in this? No. So there's 3 resources fields on the pod or at the container level with this new feature. There's the resources in the spec, which are the kind of user's desired state. There's also a resources field on the container status, which is the actual resource requests and limits that are set by the runtime. And then there's this third field, which is the allocated resources. And the allocated resources is basically when the kubelet admits the resize, it says, yes, it's got capacity for it. It reserves that capacity. Then it sets the allocated resources, and those eventually get passed down to the runtime. This is important so that, for instance, if a container is restarted, it can restart at the value that the kubelet has allocated for it. If there's a deferred or infeasible resize, it needs to track what that original what the original resources were, so that it can restart or start the container at that level, at that state. The problem is that the allocated resources field in the container status is a resource list, and it only represents the requests. It doesn't track allocated limits. So if you've got a deferred or infeasible resize, and the kubelet needs to start or restart a container, it doesn't know what the limits should be set to. There's a bug in the code today where it just uses whatever the spec says, which could kind of put the container into a weird state. So we need to track allocated limits somehow.
I'm confused on that. My recollection was that the intent originally was to quota the user's desire, not the actual observed state. And so the fact that quota right now was tracking, or my memory was that it was tracking the larger of those 2 values, was in line with the desired expectation, I guess. Are you advocating that it shouldn't?
Today, resource quota just looks at the spec. The limits, sorry, this slide is, there's kind of two different things being talked about here. There's the fact that we need allocated limits just for the kubelet to be able to start containers with the accurate limits. And then there's kind of this separate resource quota issue, which is that the resource quota has no way of knowing what limits are being used here.
Yeah, so on that last one, I don't think resource quota needed to know which one was being used versus just quoting on the larger of the intent, on the larger of the desired value.
The larger of the desired and actual, right?
Yeah, correct. Sorry.
Thank you. Yeah. So that's the that's kind of the alternative listed here. So today it's just using it's not doing the max. It's just taking the limits.
Okay. Yeah. I for quota on that second bullet, then I agree. It should just take the max between the two values.
Yeah, that might be fine for quota. But I think we still need to track allocated limits somehow. Let me talk about the kind of three different API candidates, and maybe there's kind of a fourth that you're suggesting, which is we don't need allocated resources in the API at all. Yeah, so there's kind of three options here that we're talking about of how to get this allocated limits into the API. So the first, which I think is my currently preferred option, is to add a new field alongside allocated resources in the container status. Call it allocated resource limits, type resource list. It's the simplest change. It's a little ugly from an API perspective, but functionally equivalent. It does mean that when we add pod level resources and want to be able to resize those, we're going to need to add allocated resources to the pod level, and we probably want to have the same, like a parallel API in the pod. So we would still have the separate allocated resources and allocated resource limits at the pod level. The second option is, since we can't actually change the type of an existing field, we basically say we're going to throw away the existing field and come up with a new one. So accepted resources is the best name that I could come up with, open to suggestions there. But we're basically saying we're going to throw away allocated resources. They're now called accepted resources, and we'll change the type to resource requirements, which includes request limits, and if we ever need them, resource claims. This definitely requires an extra release. There's no way we can go to beta in 132 with this change. It adds some code churn, but you get a cleaner API. I should mention that for option one, actually for all of these options, the new field needs to stay in alpha. So if we're going to beta in 132, that means that this change needs a separate feature date and would follow in 133. The third option is sort of saying, well, maybe things that are looking at the API outside of the kubelet don't actually care about container level allocated resources. They just care about the pod level. And so maybe we can just completely drop the container level field and say, we're going to eventually want this pod level one anyway. Let's just add pod level allocated resources. Its type is resource requirements. And that's good enough for everything that's reading it out of the API. We still need to track the container level one separately. And so the kubelet would have to track that internally, and it would need a checkpoint in order to track that across restarts. There were some questions about, is there any way to recover that state from the running state? And I don't think there is. So the checkpoint, this would force us into the checkpoint. With the first option, we would need the checkpoint until the field advances to beta, and then we could remove the checkpoint and reread from status as needed. Yeah, so I'll pause there, see if there's any questions on that.
I still feel like I'm being slow here. So the only reason that we need this is because the user can change not just the request value, but the limit value.
Yeah.
What if we said you couldn't change the limit value, you could just change the request value? And then got that to GA and then came back and did option 2 or 3. 2 seems, I followed 2, 3 I'm not sure I'm following, but would that be acceptable or unacceptable in your view?
Options 2 and 3 both involve dropping the original allocated resources field. And so I think if we go to beta with the current approach, then that we're kind of locked into keeping that field.
Okay. Yeah, that makes sense.
I also worry that if we say you can't resize limits, that's that also implies with the QoS locking into the QoS class that you can't resize guaranteed pods. So we're basically saying you can only resize burstable pods and only resize the request. That feels like it's too limited.
Yeah, I understand. I was just trying to play devil's advocate a little bit there.
Yeah, yeah. Appreciate it.
I guess the part that I know there's a lot of interest in this feature, but then I also know the feature has been a long time cooking. Something about 2 reads the cleanest to me. But I'm having trouble balancing, the urgency of what it means to just slip one more release then.
Mm-hmm.
3 on the allocated resources, I don't think that makes sense to me as nicely because I still find that awkward over the life of like a pod with init containers and non-init containers. And so for some reason 2, I feel like is easier for me to reason about right now.
Mm-hmm.
But
option 3 locks us into like maintaining a checkpoint to track the allocated resources across the pod lifetime. So that's a pretty strong reason to not go with 3.
Yeah, and then I guess resource overhead got included in that potentially. So yeah, it can be a bit confusing.
Mm-hmm.
Yeah, but I think to decide is we also need to prioritize what is the most important. I mean, is it to have something clean that it's long term, or we want something quick? I mean, I vote to have something long term and cleaner. So because I have a feeling that this dilemma is actually between these 2 options. Perhaps I'm wrong, but yeah.
I think one
would hate ourselves if we went with 1, and I feel like 2 is easier to understand, but I don't know if that's reality of like, again, I'm respectful of a lot of people that want the feature.
Mm-hmm. My question about 2 is there are a bunch of places in the API today that we use this concept of allocated and allocatable. Persistent volume claims have the same allocated resources, allocated resource status fields on them. We have allocatable on the node. Would it be confusing if we introduce this new idea of accepted, which means the same thing as allocated in other places? I should actually mention that the other change I forgot to include on this slide with option 2 is there's a new allocated resources status field that was added. And we would probably want to rename that to have the same parallel naming. So it would then we drop that field and add a accepted resources status.
Is there a variation of allocated that we can still use?
Resource allocation.
I can appreciate the terminology being clear. I think having just resource requirements, does seem cleaner rather than a list. I guess my gut, and I don't know, Tim, where you feel. I see you have one as the option. Is like, this feels like an API that clients will program to, and towards whichever API seems the easiest for a client to understand.
Mm-hmm.
One more is sorry, Tim. When I did the allocatable resource health thing, I was really confused with like how customers will compare spec with status if there is like different types of values for desired and for result, and it's really, I mean, you need to basically write a custom comparer to compare what you expect in spec and what you get in status. The argument to have matching types at least, or at least close enough types.
Yeah, but I have a question here. I mean, because as it is now, if we have a pod with 3 containers, and then for some reason, because it doesn't happen, this pod resize in parallel, so it's sequential. So we might end up in a case where one container was able to be allocated, but then the other container is not possible to resize. And this sequential, how can we solve it? Or I don't.
So the resize is taken as an all or nothing thing, even if it's resizing multiple containers. So the kubelet will say, can I allocate resources for all of the changes being requested across all containers or not? So you won't end up in a state where it does the resize for one of the containers and not the other. Unless they're sent as 2 different requests, and you resize one container, the kubelet accepts it, allocates it, and then you resize the next one.
Okay, good to know.
I think we're probably not going to totally resolve this API conversation here. I've been discussing it internally for, I think, weeks now. So I definitely appreciate it if folks can chime in on the KEP. I still need to update it with these options. But I propose that we move on in the interest of time for now.
But at least we are agree. The number 3 is not an option, right?
I think we can dismiss number 3.
Yeah, the number 3 we are not considered, just between option 1 and 2. But yeah, I want to simplify this one.
Okay. Let me just very quickly just kind of list out a few of the other changes, and maybe don't have time to discuss them in a lot of detail. So sub-resource, this is part of the original KEP. I'm just filling in the details here. We're going to add a /resize sub-resource. The request type will be just the full pod spec, or the full pod object. This is consistent with status, ephemeral containers, sub-resources. Bind is different. Bind takes a separate, a binding is the request type for that. And it creates a problem when you have a separate object. It makes it harder to do admission control on that. And then I'm also proposing that you can no longer mutate the resources through the non-sub-resource. So update pod, you'll no longer be able to update resources. You have to go through the resize sub-resource. Sidecar containers, not a whole lot to say about this one, other than we're going to allow them to be resized. you can't do it today. Seems like an important feature to be able to do so. So this is mostly just the code changes to make that possible. Oh yeah, so there's a CRI change that's needed. So today, the container runtime is responsible for setting the C group, configuring the C groups for at the container level. So create container configures the initial container C groups. And then there was this update container resources request that was added to reconfigure those C groups in the case of a resize. At the pod level, the kubelet is responsible for configuring the C groups. But we do pass down the pod level resources in the run pod sandbox request. And this is important for, I think, some runtimes, and they also get passed down to NRI. So I'm proposing we add a new update pod sandbox resources CRI method that would basically be an informational best effort call. So the kubelet will make that call. The runtime can pass it through to NRI or anything else that's needed. But if the request fails, the kubelet will continue with the resize, and the kubelet's still going to manage the configuration of the C groups. Any questions about that one?
If we add a new CRI method, that would, what's the timeline for, that would push beta by a release or two, right?
So my proposal is that since it's best effort, that the kubelet can basically say if it's not, if the runtime doesn't implement it, then it just continues on. So I don't think it needs to push the release back at all.
But then we won't know, like if cryo or container already have this working until this is already in beta. I guess it's beta. We can give feedback, but it doesn't really help with if there's an API change.
I think it'll be helpful to list what the runtime will do with it, like specifically how the NRI plugins will use it. Yeah, that'll make us make a call whether that's useful to add.
Mm-hmm. We already talked to the internal containerd folks about this request. So it's just not a blocker. We don't want to treat this as the beta blocker because there's no way for us coordinate. Even we add this one, right? We also cannot coordinate containerd and the cryo rollout ready. So you always have something in the Kubernetes until we can deploy. That's the problem. Yeah.
Yeah, I think I'm not opposed. Just will appreciate some detail. Hopefully, it's on the cap already.
Definitely, yeah.
Yeah, I agree with you, Murnell. The question is, what are we supposed to do with the update? Do we fail containers that are already running if the limit was restricted, or is it only increases? Do we allow NRI plugins to perturbate these updates? Probably not, right? Just be a notify only kind of thing. So that when the next great container comes in, they know what the pod's new limits are. I think that would be a fine pattern.
Yeah, the KEP goes into a little more detail about this, but yeah, it's basically it's informational, and I think the scope is should be seen as the same as run pod sandbox. So whatever is allowed to be done with the resources in the run pod sandbox call is the same for this one. There's a few more slides, but I'll stop there. There's more detail in the KEP. So yeah, please reach out to me on Slack if you have any other questions about it. But yeah, thanks for the time.
Thanks, Tim. So we have we only have a couple more minutes left, but I think we can mention a couple. So John had a note that there's a PSA that we're dropping support for classic DRA in 132 unless someone has an issue with that. So if you're on the call and have an issue with that, please chime in on the enhancement for that. or if you're calling this. Marlo, you have a hand?
I already had a discussion with John in the background, but I'm requesting it get pushed back for another bit because we are I'm at SCEDMD and we're looking from the scheduling front of how usable these parameters are. And I'd like to be able to have time to provide feedback.
Okay, cool. Well then, yes, you two can discuss that offline and potentially we won't do that. So thank you for that.
Yep.
Cool.
That also implies, sorry for interrupting. Does it also goes into our structured parameter cap going into beta, or it's not blocking beta of structured parameters?
No, it doesn't block beta of structured parameters. This is just about whether we retire the pod scheduling context and some of the other things that go along with the classic GRA. And I know Kevin also had kind of didn't want to do it quite yet. He wanted to keep it for another release, and it sounds like SCEDMD Marlo wants to keep it. So I'm okay if we want to push removal another release, and we can talk about it then. But the main reason is just it adds complexity to all of our code right now. And
the other reason is that if we move to beta, it means we have to be able to round trip all those things for classic GRA forever going forward. Right? If we remove it now, we rip the Band-Aid off, all those extra fields disappear. But if we leave it in, we go to beta, those we can never remove it, basically.
Yeah, and I also want to hear from Marlo because I'm curious what is the feedback rather than like whether we want to not to remove.
So I need some time to go through the code in detail, but from what I can tell, so SCEDMD, we do fairly advanced scheduling for many more nodes than Kubernetes can handle. And so we're trying to get that ability into Kubernetes, but when I look at the expense of processing the current things being exposed with DRA, it may be too high. So I would like some time to go through and do a comparison between what we expose in SLRMD and what is exposed in the kubelet and be able to get feedback and maybe improve that piece. The other piece is one of the problems we're trying to solve is still CPU, which I understand DRA is no longer targeted for, but was targeted for in the initial release.
Okay, let's take this discussion offline, but I am curious, Marlo, around why you need, because of the round tripping issue, why you need classic.
Yeah, I understand the headache.
Right, to evaluate.
It gives me a place to play without having to now go in and do like hard code stuff, because the classic DRA lets me use those annotations. Yeah.
Well, there might be ways to do what you need to do. Like let's have okay. So let's plan to take this offline and think about it and not quite foreclose on it yet.
That's fine.
Yeah.
I don't want to add complexity. I'm not trying to add complexity. I'm trying to remove it. Yeah.
Okay.
Cool. All right. So I don't think we have enough time for any of the larger discussion pieces or the rest of KEP planning. There is one review request, which I'm going to just bump up a little bit. Someone's asking for a review on a documentation PR, which I think we can handle offline. So if anyone has bandwidth, I've already looked at it. It looks pretty good. I think there's one more remaining piece from documentation team, but if anyone also could take a look from here, that's great. I think that we have to call it now. So hopefully we can get to the rest of the things in the future. So thank you everyone for joining. See you next week.
Thank you. Bye.
Thank you.